Welcome back everyone. In this video we're going to be creating a save and load system for Unity. This is the same system that I've used in my custom game kit, which will be available on the Unity asset store sometime between Christmas and the new year. So I'm in a brand new Unity project and this project is completely blank. So I'm going to basically aim to create a player which I can save the player's position as well as maybe the player's points or whatnot that we assign. And then we're going to save that into a file and then read that from the file and apply it back to the player. Now this system can save any sort of data, including arrays and lists and anything else that we want to save basically. Later on we will also add some sort of encryption, so it's just some private symmetric key encryption so that the JSON strings are hidden from the end user. Now there's a lot to go through and it's quite an advanced system, but it's extremely expandable and I promise you guys will not be disappointed with this system. There's a lot you can do with it. So to get started, I'm going to create my own player object because you guys probably have this set up already, but in my case, I do not. So I'm just going to create a blank square and let's just give it a position. Let's say -1, 5, like that. And then the aim is to obviously save this position and then move the cube and then load the position back from the file. We're going to create a new folder inside our asset folder called scripts. Inside the scripts folder, I'm just going to create an assembly definition just to keep our code nice and clean. So the assembly definition, I won't go too far into this, stick to the naming convention. So it's going to be com dot your first name or your company name and then your project name. So for me, I'm just going to call it save load and then dot runtime. And then make sure you change the root namespace to your project name. So for me, it's save load dot runtime. And then that's all we need to do and we can press apply. If you don't know what assembly definitions do, don't worry about it. If you don't already have one in your project, you can skip this step. This is just what I like to do because it's good practice. So the way our system is going to work is with 3 scripts. One of them is the save profile because our system is going to be able to work with multiple save profiles that we can save in different files. And that save profile is just a class. It's basically just the data holder. The main script functionality, which is going to do the saving and the loading and the reading, writing and whatnot, that's going to be in the save manager class. Alongside that, we're going to have an AES operation class, and the main functionality of that AES is just an encryption class. It's going to take in this JSON string in our case, turn that into some crazy jumbled up characters, and that jumbled up character string is what we're actually going to save into the file. So hopefully that made a lot of sense. I'm sure it didn't. So in my case, I'm going to really quickly create a player script so that I can actually test some of this functionality. So I'm just going to create a blank C# script and call it player. And then I'm going to also create a actually, let's just load up the player and I'll get started with this one first. So this player script is purely for my own functionality, just to be able to debug, log and load and do the actual saving and stuff. So you don't need to worry about this too much, but for my case, I'm just going to get rid of this, get rid of that, get rid of that. And for the first step that I want to show you guys, I'm going to debug.log application dot path, something path, persistent data path. That's the one. You can log this in console yourself and see where it takes you to, but the purpose of this is just so I can access the save folder. And let me just load this and run this really quick. So on top of the player, drag and drop this. Let me actually rename the square to player just so we know what it is. Save that, open up console, press run. Cool. Now in the console, we see the rest is blurred, but it's local low, default company, and then save load tut. Save load tut is just the name of the project, save load tutorial. Now default company, you might be wondering where that's from. If you go to file, build settings, and then here click on player settings, that's going to bring you to this window. And you'll see here product name, save load tutorial, which this by default is your project name. The company name is by default company. This can be whatever you want it to be. I would suggest naming it either your first name if you don't have a company, or if you do have a company, name it your company. When you export the project, this is actually where all the data for your project by default is going to be saved. For now, we can ignore the rest of this player script and actually get on with creating the saving load profiles and stuff itself. So inside the scripts folder, I'm going to create a C# script, and this script is going to be called save profile. Now we don't actually know what kind of data is going to go into the save profile. That's going to be completely up to what game you're making and what kind of data you actually want to save. And perhaps you want to save different types of data, not just one sort of segment of data, right? So you might have specific data for the world, you might have specific data for the player, and you want to save them in separate files. With this system, you're going to be able to do that. So to make that functionality actually work, we have to actually create a class which is pure data that we define in any way that we want. So for example, we're going to leave this class here as is for now. I'm going to create another class underneath it. And actually this class is going to be a record. So what we're going to do is create a public abstract record. Now, if you don't know what a record is think about it like a struct mixed with a class. It has kind of features of both, And realistically, you just want to use this to store data. You can use this for other things, but I don't know enough about records to speak too much about them. Abstract means that we cannot actually use this class as is. We can't create an instance of it. However, we can use this class as a template for other classes, or records, I should say. Records can inherit from other records, but they can't inherit from classes, and vice versa. Classes can inherit from classes, but not records. So we're going to call this save profile data. And this is actually going to be blank. We don't actually need to give this anything. It's just going to be a template that we can use later when we're dealing with our generic types. However, what I might do is create a public record, which I'll call save player data, or we'll call it player save data. And this is going to inherit from save profile data. So it's just going to be from the same type, essentially. Into this, we can add whatever type of data we want. For example, we might add a public. We'll add a public vector2, and we'll just call this position, right? So this is their spawn position, for example. And then we might add an array of achievements. So we'll have an int array, for example. And let's just call this achievements. And we're just going to set it equal to, I don't know, 1, 2, 3, 4, 5 for now. Just some stock data realistically. Actually, we don't even need to include this. We're just going to define it here. We don't need to give them any values. That's okay. Now, our save profile is actually going to be saving this data, but we could actually create multiple templates of data if we wanted to. So we have the player save data. We could also create a, for example, world save data, which saves just a, let's maybe say 2D array of blocks, for example. And this world save data would just have, for example, a 2D array of blocks, and that would save also into the save profile. However, again, we don't know actually what kind of data, whether it's going to be player save data or world save data, that the save profile is going to save. So this is when we create a generic sort of class, right? So to create a generic class, we're going to add these angle brackets and define t. Now t is going to be something we don't know yet, but what we do know about t is that it's going to be some type of save profile data, because both of these inherit from save profile data. So we can say where t inherits from save profile data. That way we know that t isn't going to be a mono behavior. We know that t isn't going to be an integer. It's going to be some type of save profile data. I'm also going to make this save profile a sealed class. That means that we cannot inherit anything else from this class. This is optional, but it's probably good practice. And the other thing we have to do is actually make this class serializable. What this means is that the JSON serializer can actually serialize and deserialize this class now for us. And that's pretty much the class defined. Now let's actually give some data and some functions to the class. So the first thing, obviously, like I said, is the name. So we're going to have a public string name, and this is going to be something that we define later on. And it's also going to be the same associated file name. The other thing we have to define is the save data. So we're going to have a public t, because we know that t is a type of save profile data. It might be player save, it might be world save, but we know it's some sort of data. And we're going to call this save data. And now we can create some constructors for this class. The first constructor is just the default constructor. It's an empty one. We're not going to use this. This is going to be used by the JSON serializer. So I'm just going to create a simple constructor, save profile, blank, and blank. No parameters and no actual input. It's just going to be used by the serializer. We don't need to worry about that one. The one we do have to worry about is the second constructor, which is the one we're actually going to be using to create a save profile. So we're going to create a public save profile. It's going to be some type of save profile data. So we're going to input t here. We have to define a name for our save profile when we create it. So we'll have a string name. And we also have to provide some data when we create the save profile. So we're going to have t save data. Now, as with all constructors, we can say this dot name equals name, and this dot save data equals save data. And I actually don't need to include t here, because that's by default included when we create it anyway, because that's how we defined our class. And that's pretty much it for our save profile. It's literally just a data holder that contains the name and the data. So I'm going to jump back to the player script and just show you guys how we would create a save profile. So the first step to save data is actually create the data itself. So we're going to create a player save data object. So var player save equals new player save data. And we can give this some values. So I'm just going to use curly brackets instead, and I can say position, let's set to vector2.1, and we'll multiply it by 5 just so we have something different. And we can also define the achievements as an int array or we'll say new array, and we'll just provide some values, 1, 2, 3, 4, 5. Just like that. So that's the player save data created. Now we have to save this player save data into the save profile. So we'll create a new save profile. So we can have var save profile equals new save profile. And here we have to specify a type. So the type is player save data. The name of it is, let's call it player save data. And the data we're saving is player save. Cool. Now we have a save profile. So from here, I could access the save profile using save profile.savedata.position, for example, and then I could apply this to the object later on. So I could, for example, say transform.position equals that. However, this is pretty basic at the moment because we're not actually currently saving it to a file and then reading from the file. This is literally just saving it to an object and reading from an object, which everyone can kind of do. That's the easy bit. So to save it to a file, we need another class which actually writes stuff and reads stuff from files. That's going to be our save manager. So I'm going to create another class, call it save manager. And this class is sort of the bread and butter of our system, right? So it's going to be a static class so that we can reference it from anywhere. And there only needs to be one instance of this class anyway. The next thing we have to add is a reference to the file path that we're going to save this in. So as before, we know that's the application.persistent data path. We're just going to save that as a reference so that we don't have to continuously get that. So we can just create a private static read only because this isn't going to change anyway. String, and we'll call this save folder. And we have to give it a value because it's read-only. So we can say application.persistent data path. And we're going to create another folder inside this folder, just as a subfolder. And to do that, all we have to do is add slash, and we'll call it game data, I guess. Now, this folder doesn't exist, and we have to create this folder when we're actually saving something if it doesn't exist. Otherwise, we might get some errors. But we can worry about that a little bit later. Now, the loading function is a little bit easier, so we'll start off with that one. It's going to be a public static function. And it's going to return a save profile. And we have to pass in something here because we don't know what type of data the save profile is going to use. So again, we're dealing with generics. We can pass in t here, and we'll define t a little bit later. We'll call the function load. It has to take in t, something that the user provides. It's also going to ask for a string parameter, which is the name of the save profile we're trying to load. So we'll call this profile name. And now we have to define what t is. So we can say where t is a type of save profile data. And that's the function defined. Pretty easy so far. Now there's two things we have to do. One of them is read from the file, but before we read from the file, we have to check if the file exists because we might provide a profile name which hasn't been saved, or it doesn't exist, or we spelled it wrong. Something may go wrong. So we're just going to catch that and throw our own error message so that the code doesn't entirely explode. And to do that, it's just a very simple check. We can check if not file, and this is inside system.io .exists, and here we pass in a string path. The string path is going to be our save folder plus the save profile name, because the profile name is the name of the file that we're going to save. So we can just create a string. So we'll just define this as save folder slash, and then we'll input the profile name. So if a file at this location doesn't exist, we can throw a new exception. Now the exception we throw could be anything we want, but we want it to kind of be something useful. So we can just say save profile, and we'll pass in the profile name, not found, for example. And this will basically stop our code from executing. It's going to throw a message in the console and it will pause the application running, essentially. Now, in the case where the file does exist, our code will continue. So what we're going to do is actually read the JSON or the contents from the file. It's not as hard to do. We can just say var file contents. System.io actually provides a very useful function for reading stuff. So we can just say file.read all text. And here we have to pass in the string path again. The path is just this. So we'll pass that into here. Now later on when we have to decrypt the contents, we can do that here. So we'll decrypt something, but we're not worrying about that in this video. And then we have to return the save profile by deserializing it. So to do that, we can just use the JSON converter. So we can return JSON convert inside newtonsoft.json, and we can say .deserialize object. The type of object we're deserializing it to is a save profile object, and the type of data that it uses is t, which is what we provide when we use the load function. And the contents or the JSON string that we are using to deserialize the object is just the file contents. We'll quickly write another super easy function before we do the hard bit, and that is the delete function, so with that we can delete save profiles, and that's also a public static function, and it's just a voids, and we'll call this delete. It'll take in a string profile name. Now again, we have to check if the file exists, so that's just the same thing as the load function. And then we can use the file.delete method inside system.io, file.delete, and we can pass in the file name, which is just the entire string path. And this will basically find the file. If the file doesn't exist, it will throw an exception. If the file does exist, it will delete the file. Now we can also log something in the console just when this happens, like that, and we'll say successfully deleted, just so we know what's going on, I guess. You don't have to debug it, log anything if you don't want to. In fact, it might even get annoying, but in my case, I just want to see what's happening. Now, the last function we have to actually write is the saving function, which is quite important, and that's also going to be a public static function. All these functions have to be static because we're writing in a static class. Save function is not going to return anything, so it's just going to be a void. It's going to save something, so we can save, and we have to pass in the type of data we're saving again here, because that's how we're going to know what type of save profile we're going to obtain as a parameter. So we're going to obtain the save profile using the type of T that we specify. We'll call this save, and we know that T is going to be some type of save profile data again. And now we can write the function which takes in this save profile and then saves it as a JSON string into the file that we specify. Now, the first thing we have to check is if the file already exists, because if the file does exist, then we don't want to be able to save two files using the same save profile name. So again, we're going to copy this. This time we're going to check if a file does exist. So if file exists, and here we're passing in save.profile name or just .name. In fact, let me rename this to profile name just to make it more consistent. So if file exists, save folder / save.profile name, throw a new exception, and here we're throwing save.profile name, and not found, we're going to pass in already exists. In the case where it doesn't exist, we are good to save it, so we can turn this object that we specified, the save, into a JSON string. So we're going to use the JSON convert for that as well. We can say var JSON string equals JSON convert inside Newtonsoft again. And here we're going to say serialize object this time, not deserialize. Now the object we're deserializing is the save object, serializing, and we have to provide some sort of formatting to it. So I'm just going to say indented to make it easier to read. Formatting.indented, and we actually have to provide some JSON serializer settings because Unity can sort of clash with the JSON serializer sometimes, especially with dealing with vector2s, because both of them have the normalize function and it creates some sort of reference loop. So we're just going to ignore that reference loop handling, and to do that we can just pass a new JSON serializer settings. It would be great if you don't display that message box right where I'm typing. Now instead of round brackets, I'm going to pass in curly brackets so that we can define this directly, and I'm just going to say reference loop handling equals a reference loop handling dot ignore, and that will easily deserialize the object into a JSON string. Now we can encrypt that JSON string later if we want, and then all we have to do is write the JSON string into the file. So we can say file dot write all text, and we have to provide a path to write to. The path we're writing to is the same one up here, and then we have to provide content to write into the file, which is just our JSON string. And that is it. That will write it into the file. But there is one more check that we have to do before we actually save it, and that's to make sure that the /game data folder exists. So that's super simple to do. We can just say if not directory.exists, then we can create the directory. So if directory.exists, and the path we're checking for is just the save folder. Now if that save folder doesn't exist, we know that it's because the /game data doesn't exist, because application.persistent data path always exists. So we can just say if it doesn't exist, then we can say directory.create directory, and we're just going to create save folder, and that's going to create /game data if it's not already there. So jumping back to the player, we can now save the save profile into a file. So we can say save manager.save, and we have to pass in the save profile. So we can pass in save profile just like that. and that will save it to the file. It will also log the file it saves it to into the console. Now, when I press E, I want to be able to load the data from there. So I can say save manager dot load. Now, the type of data I'm loading is the player save data this time. I have to make sure I pass that in correctly, or we might face errors. The name of the file I'm loading is player save data, and I'll just debug log this to console, debug.log. And I can say .save data. So by including .save data, I'm now obtaining player save data, which we know has a position and it has some achievements. So I can say .position. And this means it should, in theory, when I press E, it should log a vector2 with the values of x5 and y5, because it's vector2.1 times 5. So both values should be 5 in theory. So I'm going to log that and see what happens. And I'm also going to open the file inside the directory so that we can see the contents of what it actually saved. Cool. It says the directory name here. I'm going to press pause and just make sure I open that in the file. So I can Control C that. And here we have the game data folder. Inside the game data folder, we have player save data. I'm going to open that inside Notepad. And here we have profile name, player save data, and some saved data. We have position with x5 and y5. It also includes some of this other content for vector2s. We don't need to worry about that. And it also includes our achievements as an integer array. So we can save the arrays quite simply. Now, what I'm going to do is press play again, and then this time press E and see what it logs into the console so that we can see if it successfully loads it. You'll see this time I have an error because it's saying it already exists. That's fine. If I press E, it successfully loaded the data and it successfully displayed the vector2 data. So what I can do is position the square at that position when I press E now. So instead of debug logging it to console, I can simply say transform.position equals that. So now when I press play, it should move our square. So our default square position is at 5 minus 1. I'm going to set this to minus 5 and then minus 1, and we should see it move to around about here. It's a little bit off screen, but it definitely did move the square, and I can actually see the position here is 5, 5, which means that we're successfully loading the data. That's about it for this video for the saving and loading system. In the next video, we're going to add some sort of encryption so that we can encrypt the data and make it hidden from the end user so that you cannot simply open the file here and change the position. Anyway, that's it from me for this one, guys. I'll catch you in the next one. Take care and peace.